Welcome back to our second day of our series on neural networks for architects. There will be 6 small chapters on the mathematical thinking which developed in the last 120 years towards the neural networks as a technique of today. So if you are curious how to do things, go to the next day, the next and the following days. There we will go in detail. I think it's very important to get a proper understanding of what the conceptions are, because the actual doing is surprisingly simple. So you can go for details, technical details, and come back to this chapter. I think you should get these ideas. So you should not be afraid of the mathematics, because mathematics is not about formulas and proofs and so on. Mathematics is complex, I agree, but it's more about a proper thinking to get an idea of what the most uncorrupted way of state-of-the-art thinking. This, I think, is mathematics about. And I try to give you an architectural access to that with my specific metaphoric, how to get that. I think it's most in line with what mathematics is discussing and giving to you. So now we want to go for the prediction and constructing and predictions in AI. In this chapter, there are only two different applications in AI, and I don't believe there are more, for principal reasons. Again, with mathematics, it's prediction and classification. This chapter is about prediction. So it's organized like this. We have classical prediction in the 18th, 19th century, the understanding of what prediction is with statistics. I then will push on the difference on functions and equations, and I would say that AI is not with the functions. So this is gravitational. AI is not with gravity, but with light. And this is algebra, this is with equations. And therefore, then here we will go to AI predictor. And I would say this is not prediction, but contracting. So we will go in there in depth now. So a function is a predictor, I would say. It's a production line. So if, for example, there's a definition here, you can create a function. You have certain parameters, you put in values to give these parameters a symbolic name, and you apply to that a certain structure. So this is a production line. And then if you call this machine with two values as the input, then it produces an output. So that's what a function is about. If you go and say, okay, all systems, all structures are like that. So they are a kind of taking something and translating it to something else. So it's before, after. So they are lines in time. If they are a production. So if there is then here the production, and this is a product, then we can look at this. So then this is a structure, this is a system, or this is a function. And you see, this is rotating, and all these interplay of things, they work in the production in harmony, and you can't see that. So you see all the parts, but you don't see the production. You can't see the production, but you can hear it. So if it's smooth, like with an engine in a car, it's smooth, it sounds good. If there's something wrong, it's getting noisy. So production is something to hear, and it's doing. And then it's a clear contrast towards the product itself. The product you can see, and it's doing nothing. You can go around. Here you have to take your stance, and you have to hear. You can't go around, it's always the same. It's just passing by. And here you are going around. So that's the first thing. The second thing is all productions are ideals. So there's an ideal of how it should work. The product has errors. It's real instead of ideal, but there's a difference between the ideal and the real thing. So if there is a big error, it's bad. And if there's a small error, it's a good product. So there's a scale between good and bad in products, in time, in production. So because of that there is this difference between the ideal and the real. We would say this thing here is predicting the next product. So here, with a function and numbers, the only difference is that our numbers we are putting in here, what we are doing is not working with metal sheets, we're working with numbers. So we are not working with reality, so but we're working with the ideal of numbers. Therefore all this stuff in this simple form stays ideal and has no error. So it's of logical perfection. So, but it doesn't have to be like that. And with stochastics and statistics and probability, we see that we are able to deal with numbers in dirty reality. Good. Therefore, a function is a predictor. The production line and all production lines predict the products. That's, I think, very important. Next step. This is a function. So we know this primitive half of Laugier. And therefore he looks for an origin and time for all architecture. He makes a structure. He makes a system out of it, an ideal of how architecture should be. And the actual building then is a product. And it's good or bad. And all discussions in style and so on in architecture is about having good architecture. How to do that. The same with civil engineering. So you have the graphic static here, like Kuhlmann. These are ideal forms. To make them real is never perfect. Good. I think this is the first. This is prediction. In mathematics and with the same thinking in applications we know. Now, it's not very common, I think, if you have a classical education in simple mathematics, that you make this proper distinction. Here we have an equation. So if you have the Pythagorean theorem, it's not a function. So in this notation here, we simply say it's not an equal. Like here it's an equality. So we simply say a square plus b square equals c square. So there's no before and after. You simply can say, and we name that so to symbolize this with our equation. So we simply can say, give me the perspective of A. We can walk around this equation, like with the product. So it's not the machine and the production towards a product. It's just like the product. So we simply say we can go around an equation. So and see the equation from different perspectives. From A, we go look from B and we look from C. So, and it's stable. So, therefore, functions are in time, equations in space, specification and production. Equations are about constitutions and decisions in true and false, not good and bad, true and false. So then with numbers, with characters, then we are logical towards algebraic, and then functions are with engineering, and I think it's very important, therefore I'm doing all this point. Equations are algebra and they are with architects. So, and this, of course, yeah, you can do this first function, you can write that as an equation, and then you can go around all these variables, and then you have a kind of constitution in space. It's not any longer a production line. So, that's, I think, is a difference between functions and equations. So the hypothesis now is that the aliens simply work on algebra, not on logic. They are not gravitational, they are of light, which means they are not with functions, which implies they are not with predictions, they are with light. So they have alienated predictions. So this is how it works. So for example, so I don't have to say what is an addition. I simply say, now we have to get all of this. So I say the aliens are at the edge of reality, of the world, the end of time, they are out of time, and they get a picture of the world. From a certain, they're sitting there at the edge somewhere, so they have a picture of the whole world. So, and this is a picture from a certain point, a certain angle towards the world. And this is just another angle to the world. Then I got 5 examples, and the key thing what they do, they say these 2 perspectives to the world are the same. This is algebra. They simply say whatever it is, the same. And I give examples for this sameness. So, and it's completely arbitrary, as we'd seen before, what you take as the same. It's an arbitrary thing. You simply say it's the same. So therefore, this sign here as a rule implies that this is prior to that. But this is misleading. The same as that the conception of predicting is misleading. No, they are out of time, and they just take perspective and viewing to the world, like Google is looking at the world, and they say it's the same. You and me the same because we behave similar. They simply say done, and they behave like that, and they talk about us like this. So this is here. So this should be equation. They simply say this is the same. 2 perspectives to the same to natures. So, and now this is how it works. So we have in Mathematica, we have these kind of superfunctions, because it's like this. In principle, this starts a neural network or whatever, something like that, which is able to learn what's going on here. Find how to make these 2 things same. So this is a function, and now I can use this predictor, alienated predictor, as we had before. So I can have, for example, 2 plus 4. So we don't have it here. And because it's always addition here, it's able to do almost perfect prediction. With numbers, he didn't know. And that's striking. Even here with real numbers, it just works. Just with 4 examples, works. That's striking. So, if it is like that, you see, that they are able to somehow get addition just by examples without understanding anything. Just saying, okay, make these two things the same, done. Therefore, I would say, there's no reason, there's no nothing. We simply say, these two perspectives to the world contract. And they say, we are the same, and we want to have it the same, and therefore we behave like that in future cases. So it's a contract for future things, not a prediction. So, and it's rational. So it's explicitly and categorically not coupled to gravity and to the chronological traces in time. It's just a contract, and as we've seen before, we can do any kind of contracting. Then it's a question how to make good contracts. It's a political question, not a technical one, like engineering is doing. Therefore, I strongly recommend to use the conception of the contract instead of the prediction. Therefore, it's not the logic of Frege or the logic of Chomsky or what we have in architecture, Latour or Capro. We're kind of looking in data and communication like sediments and making them gravitational. It's exactly not like that. I would follow the notion of Serre. Here, these are always links to the books. It's referring to, I would say, like in, in the natural contract, it's contracting of smart elements. So, and this is for this chapter. The next will be on the second principal application on AI, which is called classification, and these arguments will develop quite the same. Thanks for watching, and see you.